Hi, it's Mr. Benson here. I just want to start to talk about what we can do with logs once we've got our log laws, and we can sort of see how you can apply those in the same sort of situations that you could with indices. But I want to show you a particularly important thing you can do with them, and that's solving equations. Now, look, hopefully some of this is familiar stuff in terms of solving equations. It should all be fairly straightforward. But we can use logs to solve equations in exactly the same way that we use other operations. So if you think about a pretty simple equation like this one here, where we've got 2x plus 10 equals 20. Now, in order to solve this, we're trying to find the value of x, so we're going to use our order of operations, which is BODMAS, but we're actually going to use it in reverse when we are solving equations like this. So the first thing I'm going to do is I'm going to subtract 10 from both sides. So I'm going to end up with 2x equals 10. Then I'm going to divide both sides by 2, and I'm going to end up with x equals 5. Now hopefully that kind of stuff is pretty straightforward. But I want to show you how you can do that with logs. So moving on to the next one. Now, this is the kind of equation where we would need to use logs, but because you're all indices gurus, you can figure out the answer for this one. So it's 1000 equals 10 to the power of x. Now, you probably go, well, I know that 10 to the power of 3 is 1000, so x is therefore 3, which is right. But we need to have a more systematic way of working that out, and so we're going to use logs. So what we do is, because the operation here is 10 to the power of x, and we know that the opposite operation is log. So what we're going to do is we're going to take the log of both sides of our equation. And remember, when I've said previously that if we're not specifying the base, we're just going to do log base 10. Okay, so now if you do log of 1000 on your calculator, you're going to get 3. Now over here we've got to do our log laws. Now we know that log of 10 to the power of x is going to be the same as log of x log 10, because that's just following the log laws. And then we can simplify this a little bit further. 3 equals x. Now x times log 10 is just 1. So it's x times 1, x equals 3. So this is a more general way of using logs to solve these sorts of equations, which will work in any situation. So let's go and have a look at one. So this is a little trickier because it's not base 10. Now, you could actually be cunning with something like this, and you could probably do it base 5, but what I want to show you here is that you can use any base and it's still going to work. Okay, so same thing, we take the log of both sides, so log of 625 equals what am I doing here, equals log of 5x, and then we can simplify that, so it's x log 5. Alright, now what I'm going to do to get this by itself, I would have to divide by log 5 on this side, so I'm going to get x equals log of 625 over log of 5. Now, I'm just going to I would just evaluate this on my calculator now, because this is not a situation where we can apply a log law in particular. So log of 625 divided by log, so I'm currently doing this on my calculator, but of course you can't see it, and we get our answer is 4. There may be a better way of working that one out, but anyway, I'll have another look at that. But hopefully you can see that by using the logs in this situation, we can always work out what the value of the exponent is here. And this is what I'd like you to have a go at doing later on in the week.